Hello, lovely Algebra 1B students. This video is going to go with the notes on factoring polynomials using GCF. To kind of get us in the mindset for what that's going to look like, I've got a review question. This comes from Algebra 1A when we talked about how you multiply polynomials. So if you're looking at this and saying like, yes, I remember how to do that, go ahead, pause the video, try it on your own. If you're looking at it and saying, wow, that's been a long time since I've done that, you can kind of follow along with me as I talk us through it. Like I said, it comes from multiplying polynomials, and when we talked about how to multiply polynomials, there was an exponent rule we used. We said anytime you're multiplying something with the same base, do you remember what you do with exponents? You add them. So that's going to be an important thing to remember when we go to multiply this. What we need to do is we need to distribute this term in front to everything inside. So there's going to be two terms we're distributing it to. When we multiply these first two terms, we could just go ahead and start by saying, well, 6 times 2 is 12. And then when we go to multiply all these variables, that's going to be when we need our exponent rule. So when I go to multiply my m's together, we said we want to add the exponents. So I would be adding 2 plus 1 to get 3. M squared times m gives us m cubed. It's like just kind of finding how many total variables you have. So you have 2 here, you have 1 here, so now we've got a total of 3. And then we could do the same thing for our n's. N times n, well, it's like 1 plus 1, so that would give us n squared. Now we get to do it all over again with the second term. So when we multiply these, I'll put my plus sign, and then we could say 6 times 5 is 30. When you multiply the m's together, what will you get? I'll get m to the 5th power. And then notice there's an n out here, but there's no other n's to multiply inside the parentheses. We still need to copy it down. So even though there's nothing to multiply it by, we can say it's still in our final answer when you multiply everything together. So this we've seen before. We called this like multiplying the polynomials. We said we have to distribute. At this point, though, you guys know how to go from something like this to something like this. What factoring is doing the opposite. So in these factoring problems, I'm going to give you something that looks like this, and you're going to change it to something that looks like this. In math, there are going to be times where we want it to look like this, and in other times where we want it to look like this. So we want to be able to go both ways. The definition of factoring, though, is you're changing something to look like a multiplication problem. So before this was an addition problem, it was this term plus this term. But when you factor something, it ends up being a multiplication problem. So notice up here, it was this term times these terms. So it's kind of changing the way the math looks. When we talk about factoring, there are actually a lot of different ways you can factor. We don't even see all of them in Algebra 1. We save some for you for Algebra 2. But the way this is going to look like is factoring using something called GCF. What GCF is it stands for greatest common factor. When you're thinking just about numbers have greatest common factors, polynomials have greatest common factors, but starting off with numbers, so for example, like 12 and 18. 12 and 18 have a GCF. The GCF is going to be the biggest number that goes into both of these. And when I say goes into, think like division, the biggest number you could divide both of these by. When you think about numbers you can divide both of them by, you might be saying 1, you could divide them both by 2, by 3, but the greatest common factor, so the greatest number you can divide both of them by is 6. So 6 would be our GCF. Now you can do that same thing even if there are variables in it. So for example, I could give you something like, let's do 12x squared y plus 18xy. If I asked you to factor that, we could factor that using greatest common factor. You would start off kind of just like what we had just done by finding the greatest common factor of the two numbers of 12 and 18, which we already said is 6. When you talk about greatest common factor, 6 is something they both have in common. But because I've added in variables, they also have variables in common. So 6 isn't the only thing in our greatest common factor because these terms have more in common. If I look at our variables, I notice they both have x. So x can be part of my greatest common factor. And I notice they both have y. So y is also a part of our greatest common factor. Now right now I just have 6xy. These variables can have exponents depending on how many they have in common. Looking at the x's, this one has 2, this one has 1, so I can say they both have at least 1x. I can't say they both have 2 x's in common because this one has 2 but this one doesn't, so it's not something they both have. So we're just going to say they both have 1x in common. Neither of these have exponents, so they also only have 1 in common. After this, I'll give another example where the exponent's a little larger. So this right here, we've started off by finding our greatest common factor. Now, thinking back to that review question we started this video with, our answer is going to look like a multiplication problem. Because I'm asking you to factor this, we want it to look like multiplication. A different type of question could just ask you find the GCF, and if that's the case, this would be your answer. But since we are factoring, I'm going to have parentheses to show what I would need to multiply this by to make this. When you're factoring things, these two things should be equal. We're just changing the way it looks. Now, there's a couple ways you can figure out what goes inside these parentheses. I'll kind of talk through both ways, and you decide which way is easier for you to think of. The first way is kind of just asking yourself, what would I need to multiply this by to make each of these terms? So, for example, asking yourself, well, 6 times what would give me 12? Well, I know 6 times 2 would give me 12. Okay. And then going on to your x's, x times what would give me x squared? Well, I need 2 x's. I have 1, so I would need 1 more x. And then for the y's, y times what will give me y? Well, I already have what I want. I don't need any more y's. I need 1 y. I've already pulled out 1 y, so I don't need any more. So these two here, I'm going to say would multiply to give me this. We're going to do the same thing for the second part. For the second part, we'll say 6 times what gives us 18? Well, 6 times 3 gives us 18. We could say x times what gives us x? We don't need any more variables. Y times what gives me y? Well, I don't need any more variables. So I'll move my parenthesis over a little bit. So this is one way you can figure out what goes inside. A different way you can do it is instead of saying 6 times what equals 12, that's just a different way of describing division. So instead of saying 6 times what gives me 12, you could always say 12 divided by 6 gives me 2. X squared divided by x gives me x. And then y divided by y cancels them out. And then same thing here. 18 divided by 6 gives me 3. And then the xy divided by the xy would cancel out. It is, again, however you prefer to think of it. Usually I do this 6 times what gives me 12 in class, just because it's written as distributing. But we definitely always have students who say oh, it's like division. Yes, it is. So it's really just however you prefer to think about it. There is one last thing I would do for this problem. Again, when we're saying factoring something, we're saying these two things are equal. I've just changed the way it looks. So the best way you can check, because you guys know I love checking stuff, is if these two things should be equal to each other, we can check by multiplying this back out to make sure that it gives us our original problem. So if I were to multiply this back out, what I like to do, because sometimes it's tempting when you know what you should be getting, just to kind of write what you should be getting, is I like to cover it up and then just focus on this to make sure I'm truly checking it. So I can cover all this up. I could say 6 times 2 is 12. X times x is x squared. And then we've got that y we got to bring down. And I could say 6 times 3 is 18. And then this xy I would want to bring down. I check, and they're the same. They should be the same because we're saying these two things are equal to each other. We've just changed the way they're written. Now, the checking part is great. I highly recommend doing it, but it is important to know this isn't the answer. This is the problem, right? This right here is our answer. This is what it looks like when you're factoring something. This is just how we can check it after we get our answer. The great thing about checking stuff too is if there's something not quite right in your answer, when you go to check it, that's going to show you what's not right. So for example, let's say I had thought there needed to be a y here. When I go to multiply that out, when I multiply these two, 6 times 3 would have given me the 18. I have an x I would have brought down, but then I would have had to say y times y gives me y squared. So when I go to look at my check and see, well, is it the same as this? I would see, well, there's something off here. These aren't right. That helps me know that it's that y there that shouldn't have been there. It helps you figure out where your mistake is. So checking isn't just great because it tells you like, hey, you've done it right, but it's great because if you didn't do it right, that's okay. But it helps you figure out where your mistake is so that you can correct yourself, which I think is something really powerful. So this is one example. Like I said, I'm gonna write down one other one that's kind of got some more fun stuff going on. Let's factor the expression negative 10 a squared b cubed plus 15 a to the 5th power. Beautiful. Looking at this problem, again, if you were asked to factor this, the first step would be finding, you're saying the words GCF, greatest common factor, then you would be right. We want to start off by finding the greatest common factor. In that last problem, we started just by focusing in on the numbers, so we could start there as well. Looking at these numbers, what do you think the GCF is? Are you saying 5? I hope so. 5 is going to be the biggest number that goes into both of these. Now there is one rule when it comes to factoring polynomials, and that has to do with this negative sign here. In general, the rule we follow is that if this first term is negative, we're going to write our GCF with a negative sign. There's actually a lot of different ways you could write something with multiplication that equals this. So you could put this as a positive, you could put it as a negative. They both would give you this, which is why we've got the rule. Like in general, we're all just going to make this first term negative, your GCF negative if the first term is negative, so that it helps us kind of all get the same answer. So we get our GCF is going to be negative 5, negative because the 10 was negative. After that, we want to see, is there anything else they have in common? What do you think? Well, you might see they both have the variable a. That's perfect. That means a is going to be a part of our GCF. Now remember with that last problem we talked about, sometimes there could be an exponent. It's going to depend how many a's they both have in common. So I see this one has 2, this one has 5. I can say both terms have at least how many a's? Would they both have at least 1? Do they both have at least 2? Well, yeah, this one has 2, this one has 5. Do they both have at least 3? Well, we can't say 3 because this one only has 2, so you can't take out more than it has. So the greatest common factor would be a squared. In general, it's always just going to be the smaller exponent. We can't say they both have 5 in common because this one only has 2, but we can say they both have 2 in common. This one's just got a little more. There's also b. Should b be in our greatest common factor? What do you think? Well, it can't. It can't because it's not a common thing. It's not a common factor. This one has b, but this one doesn't. So that means a will be the only variable in our greatest common factor. So we've got our GCF, that's this. To finish factoring it, I need to find what I need to multiply this by to make all of this. There was 2 different ways I gave you in that last problem to think through it. Think through it however you would prefer. I'm going to kind of talk through like what would I need to multiply this by to make this one. So for this first term, I'm asking myself, well, negative 5 times what gives me negative 10? Negative 5 times 2. Then your variables, a squared times what gives me a squared? Well, I don't need any more a's. I already have everything I need, so I'm not going to write anything else. And then to get b cubed, well, there's no b's in our greatest common factor, so I'm still going to need b cubed there. For the second term, if you want to pause real quick, try it on your own, see if you can come up with what goes here. You ready? Okay. The first thing, negative 5 times what would give us 15? Well, I know 5 times 3 gives me 15. What can be tricky for students is the sign, because this one is negative. Negative times what sign gives you a positive? We would need a negative sign there. You can always make that like an extra step. So instead of jumping right to the numbers, just focusing on the sign first and saying, well, a negative times what would give me a positive? Negative times negative. Then we've got our 5 times 3 gives us 15. The last part, to get a to the 5th, I only have a squared. So what would I need here to get to a to the 5th? Well, we would need 3 more a's. So I'm going to write a cubed. And then that's our answer. Now, obviously, we are all going to check it. So we could go ahead and say one last part. I'm going to check my answer by multiplying all this out. Why don't you go ahead and do that now? And we're back. When you multiply this out, we've got the negative 5 times 2 gives us negative 10. A squared times b cubed. Well, they're different variables, so we can't multiply them together. We just write them both down. And then the negative 5 times negative 3 gives me positive 15. A squared times a cubed gives me a to the 5th. And, yep, and it's the same, which helps us know we factored correctly. The only other type of question you'll see is like a shorter version of this where I just ask you to find the greatest common factor. Remember this part in the front that we find first? This is what we call greatest common factor. So I could have given you a very similar question, this exact same polynomial, and I could have just said, what's the greatest common factor? The answer would have just been negative 5a squared. Thank you so much for watching this video. Remember, if you have any questions on factoring, first of all, it's completely understandable because this looks crazy. But once you've done enough, I'm hoping that you feel more confident. But if you do have questions, feel free to reach out to me or Denise or your classmates if you feel more comfortable going to them. Anyone, we are all here to help. And then don't forget, we also have the Zoom meetings. We have the one-on-one tutoring times. You can reach out to us. Lots of different ways to get help. So please let us help you if you need help. I hope you are all doing well, staying home, staying safe and healthy if you can. Have a wonderful evening, and I will see you all soon. Thanks.